All right. So a couple things I wanted to share just to make sure, just so we're staying kind of in line. So good to see you, buddy. So this is the null, and this is the alternate, right? You feel okay with that? And I guess I should have made those H's. I'm sorry. I'm already messing things up. Can't take me anywhere. Okay, so friends, I want you to start kind of thinking about this. The null hypothesis would be like there is no change. There's no change. So basically, think of if you had a mean and then you had a margin of error, basically like this. So what this basically means, if we created a null hypothesis, we're basically saying there's not a change in something taking place. Okay? Meaning if we were to recollect our data, we would be able, if we incorporated like a confidence interval into it, we'd be able to say, hey, we're 90% sure or 95% sure or 80% sure, whatever, that something's going to take place. Okay, so that's basically that's where we're looking on the null. So if I had done this, I'm going to make this yellow. And I'm also going to make it green. So if you said, hey, if you created a null hypothesis and there's no change, and then someone said, and then you created your alternative hypothesis says, this will be less than, you're talking about the yellow. If you said this will be greater than, you're talking about the green. If you incorporated both the green and the yellow, that's where it becomes a two-tail, and that's where the tails come from. It's the outside as you're going away. One tail would be if you're just going towards the yellow, if you're looking for things less than. If you're going towards the green, it means you're going greater than. And if you just said, what we're trying to aim towards is your null hypothesis is not going to have, you're hoping that it falls in here. This is where your null falls into your thinking. And then these two regions, one tail is left or right, and two tail is left and right. Okay, does that make sense? Okay, so the normal distribution, we have done normal distributions over and over and over again, and I think you're doing well with that. I think you have a comprehension of it. And I just wanted to kind of bring from the past, kind of visually, this is what you're looking at when you're talking about a null hypothesis. Okay, if you were to say, hey, we are 90% sure that our parameter within the margin of error is this, it's that center region. And again, I don't know what the margin of error is going to be. That's basically, it's a standard deviation, but it's really a z-score, because a z-score is a standard deviation that has a decimal in there. Okay, so it's how wide that region. Of course, if we say we're like 99.9% certain, our margin of error is very, very wide out. Okay, and then the other thing. So then we started talking about yesterday a p-value, and that's the probability of obtaining a result at least as unlikely as the one we obtained by random chance. So what that means is, if I had, and I always bring up the ACT question, which is a goofy one, but we all know that the ACT test is a test that's out there. The majority of us, I would imagine, have taken it at some point, or at least thought about taking it at some point. But there's an unbelievable amount of data. So when we are running our iterations of selecting from a huge sample, we have a huge population of something, I'm not going to look at the entire population. I'm just going to start taking random amounts at a certain thing. And again, if we created over 30, which is great, that says something that it falls into a normal distribution. If we have less than 30, then we start using the t distribution, which is very similar. It's when we have less pieces of data. So that's kind of where we are. And then with the p-values, so a p-value is basically the probability obtaining a tail, and whether it's one or two tail, depending upon what you're testing. Okay, that's kind of the thing. So lower p-values. So a p-value is a percent. A percent goes between 0% and 100%, which if I convert those to numbers is between 0 and 1. So a lower p-value close to 0 means one thing. When it's close to 1, that's something else. It's like if you had a p-value that's like 0.96, that's a 96% chance that that event's going to take place. Okay, that's where we could start saying, either one of those, whether it's close to 0 or it's not close to 0, that's where we can take our hypothesis and we can use the terminology that they say on the page before on the notes. It says we can reject the null hypothesis or we can fail to reject the null hypothesis. So let's put those terms back on this page. So reject the null means a tail is happening. And again, it could be one tail, it could be two tail, depends upon if we're looking for a directional value less than or greater than would be a tail, a one tail. And then if it says there is a difference, then that's a two tail. Okay. So that's, if I reject the null hypothesis, that means this or this is going to take place. If I change the terminology and I say that we fail to reject the null, that means that something's taken place within this region. Okay, or we have evidence that takes place within that region. Okay, so that's, we got coupons. I got this dude and I got that dude. Perfect, appreciate you. All right, so again, a p-value close to 0 means something. A p-value that's close to 1 means something else. So we had finished with this, but they say that our H naught has to do with sugar. Sugar leads to insomnia or not sleeping, lack of sleep. Our alternative is that sugar, if I could spell, I'd be so good. Sugar, that's an A. Sugar increases insomnia. So it's one tail because an increase in insomnia. So you'd be looking to the right on our normal curve. So if our p-value is low, so close to 0, our p-value is low, then we reject the null because the evidence evidence that sugar increases the insomnia. If our p-value is high, so close to 1, then we fail to reject the null, and this says that there's evidence not found in sugar to insomnia. Oh my gosh, it's getting really bad. Insomnia. Okay, so that's really kind of where we're at with this information so far. So again, let's go back to this. If we reject excuse me, if we rejected the null with the sugar intake, we're going to the right, okay, because that showed an increase in insomnia. It's one tail. If we fail to reject the null, that means that we didn't find evidence that this tail happened, green tail happened, which points to there's not a correlation between sugar consumption and sleep insomnia. Okay? So I don't know if there is a correlation or not. I can tell you that I ate ice cream last night before I went to bed, and I slept like a baby. So is that enough evidence to say that sugar affects sleep? No, I just gave you my perception. I just happen to like ice cream. It was chocolate, and it had peanut butter swirl in it. Dude, yeah, life is good. My wife's always like, there's 8 servings in this container, and I seem to be able to make 8 serving container turn into 3 servings. Sorry. It's only 3 servings because my wife's watching. I'd make it 1 serving if I had to. But of course, my wife's like, no, you should be eating this much. It says 2/3 of a cup. 2/3 of a cup of ice cream? Are you kidding? That's not enjoying ice cream, man. Ice cream is meant to be enjoyed, in my opinion. So this is where we are with this. So at the middle of page 28, it says the p-value itself is a proportion or a percentage. Okay, so it could be a fraction between 0 and 1. It could also be a percentage, or it could be a decimal between 0 and 1. It represents the probability of obtaining a result is at least as different from the null hypothesis as we obtained. In our study above about the sugar, it says let's assume the data produced a p-value of 0.13 or 13%. So they are saying that the sugar produced a 13%, which is 0.13. Okay? So this is what this would mean, and this has to do with sugar increases insomnia. And again, we are testing our alternative hypothesis. Our original hypothesis, sugar is not equal to insomnia. And notice I'm starting to make these shorter and shorter, and I'm making them shorter and shorter for a reason. Because basically what you're going to start doing is you're going to start using greater than or less than signs. Okay? So in this case, if sugar consumption does not produce insomnia, the probability of obtaining an increase in insomnia at least as great as the one in our study by random chance is 13%. Okay, let's say that one more time. Let's see if we can write that so it's a little nicer. Sugar does not produce insomnia. Okay, so the probability that we found that it did increase insomnia by random chance is 13%. Okay, what this basically means in just easy lingo about sugar intake, we did a study, and then someone says, okay, you have a p-value of 0.13 or 13%. That means you have basically a 13% chance that you randomly pick somebody else that's a part of this study that they're going to fall off. They're not going to sleep well because they had sugar. Okay? So, friends, do you want a 13% on a test? Heck no. I want the good stuff. Thank you. So that's what we've been doing. All right, now it says, so informally, our result like ours could be obtained by random chance 13% of the time. That's pretty low. But is it low enough to reject the null hypothesis? And that's a source of debate. So then they say this, and this is kind of an accepted parameter. If p value is below 5% or 0.05, we reject the null hypothesis. Okay? That's pretty low. You have less than a 5% chance. If that takes place, there is enough evidence at the 5% that we could say we can reject the null. So, I mean, a p-value is extremely low at 0.13, but 0.05 or 5% versus 13% means something. So, the 5% is an acceptable value statistically that's proven to show that we could, have to reject the null in this case. Okay? All right, so now I need to find, I'm looking for, I have a page that's off. So I have this cholesterol example here. That page is in the wrong spot. Page 29 is in the wrong spot. And I'm just trying to figure out where in the heck it actually goes. Trying to. Yeah, I don't know where this. I don't know where that page 29, because it doesn't flow into it, because it says let's go back to our cholesterol example from the previous page, and I don't see a cholesterol example anywhere on 6.1, 6.2, or 6.3. But I can tell you that the answer on page 29, the normal CDF, the 44.4% is actually wrong. It's actually should be 9.1%, but that's a whole different area. So maybe I'll figure out. I'm gonna put a note. Find where. All right. So, friends, do you feel okay with this? All right. So, would you start on page 95 96. I'm happy to help you. And I know there's going to be, it's going to twist your brain around a little bit, but work on those 2 pages and we'll definitely go over those tomorrow. I would imagine there's enough of that for us to go over tomorrow that would probably mean that I wouldn't be able to cover the next lesson. And I think we would have Tuesday of next week, we would have a quiz on 6.1 to 6.3. Sound good? All right, friends, you know what to work on?